So your dual arm vision guided robotic manipulator. Tell me about that. Is this the product that you're bringing to market? Is that what it's
So this is
called?
the product behind. Yeah, this is the
Yeah.
product that we actually bring it to the market. One of the foundational understanding is that it comes from the coin analogy that I actually said. When instead of trying to improve your recognition algorithm, you need to find out how I can, with a very basic level of recognition in itself, how can I adjust myself to see the right image so that I can construct it. So you need to bring that basic adaptiveness. It kind of imitates the freedom of movement that a human upper torso actually has, but it's not exactly the same. On the other hand, we are leveraging the technology that is already available. Robotic arms have been there for 40 years. They have made it really, really precise, reliable to work for 5 years inside a factory in all those harsh environments. And what we are trying to do is to use all those capabilities to bring in the basic capability that a human upper torso has, so that you can do any kind of flexible tasks, right? So it's a form factor that has a camera on top of a robotic arm, which simulates your whole trunk, and then two other arms which are independent from this trunk and then can move freely, right? So you have close to around 18 degrees of freedom. Including the camera, you almost have 21 degrees of freedom. And with that, you will be able to do any rigid object manipulation or sophistication on top of a tabletop. And when the same system is mounted on an AMR, an autonomous mobile robot, it can also be a mobile alternative to human form factor, right? We certainly do not believe human form factor necessarily have to be the only way by which you can automate. There are other more sophisticated ways by which you can achieve same tasks, probably sometimes much better than what a human or human form factor could do, right? Of course, from a versatility point of view, a lot more relies on the human finger and so on and so forth. Those are the factors that we'll be building more and more and more as time passes by. But right now, this is the basic form factor, which we think is more of an universal form factor for wide varieties of applications that comes under either part mating or part kitting for any assembly tasks.
I needed to touch on your cybernetics laboratories, or the technology that you're bringing to the North American market. Tell me about this project. Explain, well, what it is and why you're targeting the North American market.
I think from a application point of view, we are kind of sector agnostic. When we are trying to bring, so the idea of cybernetics is to bring basic level of intelligence, the small blocks of intelligence that you can build to make systems more dynamic. That's what we are thinking about. And our biggest goal is to bring universal factories where one line or one assembly line or a factory line that you build is very highly defensible from part variations or object variations, where you can keep producing multiple varieties of objects out of the same line, right? So if you have just because you're built for, let's say, your IC engine, it should not cost you again the same amount for you to repurpose them for an EV part. You can just use the same line for both of these to simplify automation specifically, right? And in places where automation of the dire necessity, especially in developed nations, this is something that we think is a very important technology that is missing to make it easy for customers to adopt automation or make it reliable for them to utilize the automation. North American, like I said, from that perspective, application-wise, we are sector agnostic. Anywhere where you need to manipulate objects, our systems are applicable. But from markets that are ready to absorb, we are looking at geographies and sectors which are very, very convenient or would appreciate it really well, right? From that sector, first category is to have a developed nation, whose price point for a nascent technology with our limited supply chain, it still is profitable for a customer to absorb the system at that price point. Second, they also have a sophisticated ecosystem, engineering ecosystem, which can absorb this and successfully make it work. They have a way to make it work. Now, automotive is one of the most mature segment and sectors which have been making use of even a much more dumber robotic arm than what we actually built. They have the know-how, they have the engineers, they have the processes, they have the machinery and ecosystem, system integrators, everything built, who have a very long years of how to use robotic arms, how to put robotic arms to use. So that's another reason why we are again looking towards North America and automotive sector specifically, and also warehouse sectors and probably electronics manufacturing.
Can you describe what you mean by product agnostic robotic assembly lines?
Absolutely. So I just want to bring the picture of the how the automation happens today, and then why the machinery is too tied to the shape of the object in general. And because it's tied to the shape of the object, when a product changes, the shape of the objects also change. And because of which you are not, and the processes associated with that, and so on and so forth, because of which you are not able to transition, repurpose the same machine from one to the other, right? Now, simplistically, if we think about what a factory is, it's like a magical hand that goes into the earth, pulls the raw material of a particular shape. And shape is what utility is for us, right? Like, for example, this robot is made of the aluminum. The base is also made of the aluminum, but are they both for the same purpose? No, they both are of entirely different purposes. Why did they have a different purpose? A fork and a knife, why are they used for different purposes? Because of the shape, right? So the shape extracting machine, the shape machining system is your factory, essentially, right? And to be able to do that, whenever you want to carve out material, which we called as a reduction process or an additive process by which we put together this material, and then you also have to attach parts together. These are the basic tasks that you're doing, which I equate to arithmetic and logical unit, right? So arithmetics is when you are adding or subtracting material, and logic is when you're attaching to moving materials to one to the other, right? So you're doing this is the fundamental function that you're doing across all factories. But why do one factory look very different from another? Because the machinery is for the shape or the outline of the shape. So whenever that changes, you are not able to change. How much has it changed from your EV to your IC engine, right? Many of them share a metal part. Just because the metal shape, the part shape has changed, every time part shape changes, your infrastructure is unusable. That's what we want to change. How do we change them? If the robotic arms or the machines are capable of adapting themselves to the varying shapes, then the same machine can be repurposed for multiple different shapes. Like CNC machines do not change from one shape to the other. You can use the same CNC machine, whether to manufacture this key or the keychain, right? Why aren't the robotic arms usable that way? Why aren't the conveyor systems usable that way? Why aren't the rest of the other factors usable that way?
Fascinating. Your work's very, very interesting, Gokul. Thank you so, so much for sharing everything that you do. And I really want to wish you well. Good luck with everything.